Good morning, class. We are looking at Chapter 9, Systems of Equations and Inequalities. Here, Section 9.3, Systems of Nonlinear Equations and Inequalities. We covered systems of linear equations in 2 variables, 3 variables, and now systems of nonlinear equations. The objectives are to solve a system of nonlinear equation using substitution, elimination, graph a nonlinear inequality, graph a system of nonlinear inequalities. Recall system of linear equations. System of equations, a group of 2 or more equations by definition. They can be solved by graphing, substitution, addition, and so forth. Types of systems. A system of 2 linear equations in 2 variables can have 1 solution, no solution, or an infinite number of solutions. Inconsistent system is the system that has no solution. The graphs are parallel lines. They have the same slope but different y-intercepts. If you solve them by substitution or elimination, it ends up giving you a contradiction such as 0 equals 7. Consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. So basically, 2 lines with different slopes must have a point of intersection. Consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. In other words, if you solve for y, they become identical. So m1 equals m2, b1 equals b2, and if you solve it by substitution or addition, it ends up giving you an identity as an example. 0 equals 0, that indicates system has infinite number of solutions. The equations are dependent. System of linear equations, 3 variables. Types of system. A system of 3 linear equations in 3 variables, similar to system of 2 linear equations in 2 variables, can have 1 solution, no solution, or an infinite number of solutions. The equation 2x minus 3y plus 4z equals 8 represents a plane as an example in space and is an example of a linear equation in 3 variables. The solution to this type of equation is an ordered triple of the form x, y, z. A consistent system of equation with unique solution. There is a single solution. If the planes intersect at a single point, that ordered triple is the solution to the system. Here's a point of intersection for all 3 planes. Dependent system of equations. We have infinite number of solutions if the 3 planes intersect along a line, such as this one. The system has infinite number of solutions, which are the coordinates of any point along the line. If all 3 graphs are the same plane, the system has an infinite number of solutions, which are the coordinates of any point in this plane. Example, you obtain a statement that is always true, such as 0 equals 0 if you go through the process. Finally, an inconsistent system. An inconsistent system of equations with no solution. If all of the planes are parallel, the system has no solution. Pairs of planes also can intersect as shown. However, because all 3 planes do not have a common intersection, the system has no solution. Example, you obtain a statement that is always false, such as 3 equals 0. If you look at these 3 planes, they are parallel. If you look at these 3 cases, 2 of them meet in a line, but not all 3 meet at the same point or line. So these are examples of inconsistent. If you were to solve it by any method, you would end up with a contradiction. Now, section 9.3, nonlinear system of equations. A nonlinear system of equations is a system of equations in which at least one equation is not linear. That is, one whose graph is not a straight line. For example, we are looking at a parabola and a line, no points of intersection, no solution. Same situation, there is one point of intersection, therefore one solution. In this case, the line goes through it and crosses the parabola at two different points, 2 points of intersection, therefore two solutions. Let's look at examples. Example 1, solve x squared plus y squared equals 20, y minus 2x equal to 0. You may remember this is a circle. Okay, you can even graph this. This is a circle centered at 0, 0 with the radius square root of 20. And this is a line. So we are going to go through the process that we have learned. Elimination, substitution, you name it. Notice this is y minus 2x equal to 0. It's easy to solve for y and put it into the first one. So first we solve for y in the second equation. So y equals 2x. Now we go to the first equation. It's a good idea to give them numbers. Okay, the first equation, x squared plus y squared equals 20, and we're going to replace the y with 2x. This is 4x squared, and x squared, they add up to 5x squared. Divide by 5. X squared becomes 4. X becomes plus minus 2. So x is either positive or negative 2. So it's easy to put that into the two. Let me just erase my work. Into one of the original ones. Even if you put it here, it's fine, but you have to check it with the original one. So if I say y equals 2x, that means when it's 2, it's 4. When it's negative 2, it's negative 4. So 2 comma 4, negative 2 comma negative 4. We must check. How do we check? I want to make sure everybody understands what's happening here. You have to check. Basically, we use the second equation to find the y. Now we're going to use the first equation and check. For example, if I put 2 here, I'm going to check this one, everybody. I'm going to check this one. So I put 2 squared plus 4 squared. As you can see, 4 and 16, they add up to 20. That checks. If you put negative 2, negative 4, that checks also. I can't emphasize the importance of checking. And that's the beauty of the math. You can check your work, okay? You can check your work. So it's extremely important that you do so, okay? Now, we can also look at the graph. As I mentioned, the first one is a circle centered at 0, 0 with the radius being square root of 20. Square root of 20, remember, square root of 16 is 4. Square root of 25 is 5. So square root of 20 is somewhere in between. That's why you get a number between 4 and 5 for the radius. And y equals 2x. You can see that there it goes through 0, 0. And for example, 1, 2, just as an example. So you can see it's easily graphed. Okay, everybody. If in case they ask you to. Here's the second example. 3x squared plus 2y squared is 66. 2x squared minus 2y squared equals 14. And we are going to solve this by the method of our choosing. They are asking for the addition, but even if they don't, because the coefficient of y squared here and here, they are opposites, that is the fastest and easiest way. Just add these two. That's all you have to do. Add them up. This gives us 5x squared, 14 and 66, 80. Divide both sides by 5. X squared is 16. And x must be plus minus 4. So we have two x coordinates. We are going to go to one of the equations. And it doesn't matter which one. For example, we can go to the second equation. By the way, notice that both sides are divisible by 2. So you can write x squared minus y squared equals 7. If you want to do that. Seven. And then plug in. Whether you plug in positive or negative 4 makes no difference, because when you square them, both of them result in the same number, namely positive 16. So 16 minus y squared is 7. Move the 16, you get negative 9. Therefore, y squared is positive 9. And y is plus minus 3. So that's very straightforward, everybody. So I have two answers for x, two answers for y. How do you write that? The system has 4 solutions, and I can't emphasize this enough. You have to write all 4 solutions. Four, 3. Positive 4 with positive 3. Positive 4 with negative 3. Negative 4 with positive 3. Negative 4 with negative 3. And you want to check. Remember, we used the second equation to get y, so it works. Let's check it with the first one. But if you have any doubts, put them into both equations. So I'm going to pick one of them. For example, I'm going to pick this one, but you really have to check all of them. So I'm going to check this one. And I'm going to check it with equation, let's call it equation number 1. 3 times negative 4 squared plus 2 times negative 3 squared. Is it equal to 66. So this is 3 times 16. This is 2 times 9. This is 48. This is 18. And they add up to 66. That works. You really have to check all of it. And again, as I've mentioned before, it's really easy to check, as you know. So it's really a good practice to do so, because with math you can do that. Let's go with the application. Given the rectangular area of 48 square feet along a riverbank, as illustrated, find the dimensions if 20 feet of fencing is needed. So if the variables are given, so be it. If not, you define your variables. The width is X, the length is Y, the area is 48 square feet, X times Y. You have 20 feet of fencing. The perimeter is 2X plus 2Y normally, but this side doesn't need it. Therefore, it's 2X plus Y equals 20. Now, we solve for Y in this equation, we get 20 minus 2X. We put that into this equation, X times Y equals 48. We're going to replace the Y with 20 minus 2X. We get 20X minus 2X squared equals 48. Now we bring all to the same side and we put it in descending order, which means this becomes 2X squared, this becomes minus 20X, this is plus 48. Okay. Since we want to solve this, we're going to factor, and the very first thing is to factor the common factor 2 out. We get X squared minus 10X plus 24. So we keep the 2. We want two numbers. The product is 24. The sum is negative 10. So both of them are negative, negative 4, negative 6. And so if you set this equal to 0, X is either 4 or 6. Sometimes one of the solutions don't work. I want you to know that. But if we put that back into one of the equations, we can find the other one. For example, if you put it here or here, it doesn't matter. Even if you put it here, you have to check the one. 20 minus 2 times 4 is 8. 20 minus that is 12. So if you go with 4, Y becomes 12. What about 6? Times 2 is 12. 20 minus that is 8. It so happened that Y is either 12 or 8. That means 4 by 12 or 6 by 8. Now you have to really check the product of these two numbers, and the product of these two numbers, both of them is 48. So the area works. If you multiply this one by 2, add it to 12, or this one by 2, add it to 8, you do get 20. So you should check Both happen to work. In many cases, only one set works. Or in some case, maybe, for example, if any of them is negative, is out because dimensions can't be negative. A gate is shaped like a right triangle with a perimeter of 36 meters and a hypotenuse of 15 centimeters. Find the length of the legs of the triangle. So let's see what we are given. First and foremost, the perimeter is 36. So A plus B plus C, and C happened to be 15, right? That is given. C, the hypotenuse, is given as 15 meters. So that means A and B and C, which is 15, they add up to 36. Also, we know Pythagorean theorem, A squared plus B squared equals C squared. C happened to be 50. So these are the two equations. One more time. The perimeter is 36, so A plus B plus C is 36. C is known to be 50. Because it's a right triangle, then Pythagorean theorem applies. Okay. So it's pretty straightforward, everyone. We're going to solve this. So this one, we want to solve for B. So first and foremost, 15, combine it with 36, you get 21. In other words, subtract from both sides. A plus B is 21. So B is 21 minus A. We put it into this equation, which means A squared plus B squared is 21 minus A quantity squared. And 15 squared is 225. We are going to work on that. So A minus B quantity squared is A squared minus 2AB plus B squared. So square this one, 21 squared, 441 minus, when you multiply this one by 2, you get 42. So minus 42A plus A squared equals 225. So we are going to work on this, as I mentioned. Just take the steps. So A squared and A squared is 2A squared. So we combine these two, get 2A squared minus 42A positive 441 minus 225. The reason we move everything to one side is because we want to be able to factor. 441 minus 225 is 216. So we get 2A squared minus 42A plus 216 equals 0. You take out the common factor of 2 here. Two times a squared minus 21a plus 108. You can do factoring, or you can use the quadratic formula if you, for any reason, it's difficult to do the factoring. Remember, this is a and a. You want two numbers. The product is 108. The sum is negative 21. Both of them must be negative because the product must be positive and the sum remains negative. Okay. And for example, 1 and 108, 2 and 54. Okay. 4 and 27 and so forth. So you get to, you can play with numbers. 9 and 12, both of them negative. So a is either 9 or 12. When a is 9, you put it here, 21 minus a gives you b equals 12. But if a is 12, 21 minus 12 gives you 9. The idea behind this is you're really not getting two sets. In essence, is that what this says, the two legs, one of them is 9, one of them is 12. One of them is 9, one of them is 12. That's all it tells you. And to check, all you have to do is quickly add them up. 9 and 12, 21 with 15. Let me erase my work so we can see that. So 9 and 12, 21 and 15. Okay. They add up to 36. Yes. 9 squared, 12 squared. Does it add up to 15 squared, which is 225? That checks too. So checking doesn't take long, everybody. So you really want to do that. Checking is extremely important when it comes to any work in math, especially systems, because you can easily, if you made a mistake, you can easily catch it when you check, and literally takes seconds. All right. Solve the system of equations. X squared plus y squared is 9. 2x squared minus y squared equals negative 6. And basically, we don't have to do much. Notice, if you just add them up, these two cancel each other. So you end up with what? 3x squared equals 3. Divide by 3x squared becomes 1, and therefore x is plus minus. Very simple. We got two answers for x. We are going to go back to one of the original equations. Either equation 1 or 2. We're going to go to equation 1 and plug in plus minus 1. It makes no difference to put positive or negative because it gets squared and therefore it becomes positive 1. So 1 plus y squared is 9. Y squared becomes 8. Y is plus minus square root of 8. 8 is 2 times 4. 4 comes out as 2, so plus minus 2 square root of 2. You have to write 4 solutions, and I can't emphasize this enough, everybody. You have to write 4 solutions. How do you write them? positive 1 with positive 2 square root of 2. Positive 1 with negative 2 square root of 2. Negative 1 with positive and negative 1 with negative 2 square root of 2. That results in the following 4 solutions. And you must check. So we pick one of them and check. Remember what we used. We used equation number 1 to get to the answer. So you really have to check with equation number 2. So equation number 2 and one of them. For example, let's say we are going to check this one with equation number 2. So 2 times x squared minus y, which is negative 2 square root of 2 squared, is this equal to negative 6? And I have a question mark because we are checking. So negative 1 squared is 1 times 2. This becomes 2. As you see, if you reverse the process, you get 8 here, right? So this is minus 8, and it's equal to negative 6, and checks. So you really should check your work. It doesn't take long, everybody. We want to solve this system where x squared plus y squared is 25, 3x plus 4y equals 0. And whenever you have a case like this, one of them has of degree 2, one of them doesn't, it's easier to go by the substitution. So over here, we're going to solve for one of them. It doesn't matter which one. So I hope you recognize if I want to solve for y, I take the 3x to the other side and divide by 4. I get minus 3x over 4. So from here, let's give them numbers. Equation number 1, equation number 2 results in y being negative 3x to the power of 4. We're going to put that back into equation number 1. X squared plus y squared. Y is replaced by negative 3x over 4, quantity squared equals 20. This is x squared. This, when we square it, we get 9x squared over 16. We have a fraction. We want to solve this. Let's get rid of the fraction. What is the fastest way of getting rid of the fraction? Multiply both sides by the denominator 16. So multiply this one by 16, multiply this one by 16. This gives you 16x squared. This cancels out. This one gives you 9x squared. 16 times 25 is 400. So you have an equation involving a fraction. Multiply both sides by LCD. The reason I say LCD, if you have more than one fraction, there's only one fraction, just the denominator. 16 and 9, 25 x squared. I mean, 16 times 25 is 400. So the answer is 16. X is plus minus. So we have two answers for x. We are going to put that into one of those equations to find the y, and you can put it into the second equation. If you believe you haven't made a mistake, you can even put it here. So if you replace the x with 4, 4 cancels out the 4, you get -3. If you put -4, -4 cancels out the 4 and gives you -1 times -3 gives you +3. So I hope you see from here, again, replace the x with 4, cancels out this one, the answer is -3. Replace it with -4, -4 cancels out the 4, but it gives you a negative sign with -3, +3. So either we have these two, 4 comma -3, or these two, -4 comma 3. So what should we do? I want to make sure we understand the process. We used the second equation to find the second variable, namely y. We are going to use the first equation to check. So I'm going to check one of those pairs. For example, we're going to check this one with equation number 1. So we're going to check it with this equation, x squared 4 squared plus y squared -3 squared. Is this equal to 25? This is 16. This is 9. They add up to 25. And I checked the first pair. The second pair is just as easy. Again, it literally takes seconds, class. So when you solve a system of equations, you check your work. Always check your work. Does not take long. It's worth checking. I can't emphasize this enough. Solving linear inequalities. Linear inequalities are inequalities in one of the forms ax plus by less than c, larger than c, less than or equal to c, larger than or equal to c. When it's just less than or greater than, the line is not included as part of the solution. Use a dash line. When we have the equality, the line is included as part of the solution. Use a solid line. So that's extremely important to understand when to use the line and when not to use the line. Dashed or solid. Graph the equality ax plus by equals c and pick a test point x comma y not on the line. If the test point results in a true statement when put back in the inequality, that side is the solution. Otherwise, the opposite side is the solution. So when you have a line, it cuts the plane in two half planes. That, for example, x plus by equals c, the top and the bottom, or you might say the left and right. Okay, that's the result of having a line and half planes. Now, warm-up example, we want to graph y less than 2. So obviously, y equals to is a horizontal line. And the reason we go with dash, we don't have a equality. There's really not much that you have to, it's less than 2, so below that. Okay, and that would be an example of a test point. If you plug in 0, 0, you have to go with the y coordinate. 0 is less than 2. Y is greater than or equal to 2x. We're going to graph the line by picking up a couple of pairs. Obviously, 0, 0 is one pair. it goes through the origin. If x is 1, y is 2. So 0, 0, 1, 2. So let's graph 0, 0, 1, 2, draw a line. Now, is this dashed or solid? Because it has the equality, it's solid. Otherwise, we make it into a dashed line. Then you pick up a test point. Any point that is not on the line will do it. For example, 1, 0 is not. Now, you put it into the inequality. It makes a true statement. This side is the answer. It makes it a false statement. The opposite side is the answer. So 1, 0. So if you replace the x with 1, you get 2. Y with 0, you get 0. 0 larger than or equal to 2 has the equality also, class. No, it's a false statement, everybody. That is a false statement. So false statement means this side is not a solution. So you shade the opposite side. Okay, you shade the opposite side. And that's all there is to it, class. Very straightforward. So solving system of linear inequalities, graph each inequality on the same axis. The solution is the set of points whose coordinates satisfy all inequalities in the system. We want to graph the solution set for the system of inequalities, x plus 2y larger than 5, y less than 3x minus 2. So first and foremost, we're going to go with the line. For this one, the line is x plus 2y equals 5. And we're going to pick up 2 points if x is 0, y is 5 halves. If y is 0, x is 5. So I'm assuming we have no problem picking up pairs very fast. So we have the pairs 0, 5 halves is here. 5, 0 is here. And the line, because it has the doesn't have the equality, is a dashed line. The second one, y equals 3x minus 2. And for this one, we do the test point. 0, 0 is the best test point if it's not on the graph. And if I put the 0, 0 into the original inequality, I get 0 plus 2 times 0, which is 0 larger than 5. And that makes it a false statement. And so if 0, 0 makes it false, the opposite side is the solution. So you shade the opposite side, okay? So we're done with the first one. Again, imagine you have only one, and then go with the second one the same way, y equals 3x and minus 2. Uh, if x is 0, you get minus 2. If y is 0, you get 2/3. I hope everybody is okay with that. Both lines will be dashed, of course. So we draw this line. Again, you can see the pairs. Zero, negative 2, 2, 0. That 0, 0 works as a test point here too because it's not on the line. So if you put the 0, 0 as a test point into the original inequality, the second one, 0 is less than 3 times 0, 0 minus 2. 0 is less than minus 2 is also a false statement. So that means it's the 0, 0 is not a solution. It's the opposite side of that. That means for the blue line, this side. And then the solution for both of them, look at the red versus blue. This is the one which is red and blue. This is the solution. Please understand, two lines cross, it creates 1, 2, 3, 4 regions. This is the only answer, this region. So maybe I do it like this. I want to make sure that we understand this region is the solution. So that's how how it works, everybody, okay? So I hope everybody's fine with that. We are going to move on, everyone. Graph the solution set for the system of inequalities. Y is less than 3, 3x minus y is greater than or equal to 6. So for this one, we draw y equals 3, which is a horizontal line. So this is y equals 3. So and it says y less than 3. So that means clearly it's down here, right? So this is the solution for the first one. The second one, 3x minus y larger than or equal to 6, we change it to equality. And we pick two pairs. If x is 0, y is negative 6. If y is 0, x is 2. So 0 minus 6, 2, 0. So zero minus 6 is here. 2, 0 is here. We try. And again, 0, 0 does not belong to the line. So that is a good test point, everybody. This doesn't belong to the blue line. So you check it with the original inequality. If I put 0, 0 into this one, I get 0 larger than or equal to 6. That's a false statement, everybody. Therefore, this side is not the solution. It's the opposite side that is the solution. So notice the red and the blue, they meet here again. Look at these two lines. There are 1, 2, 3, 4 regions. When you have class, maybe it's easier to see it this way. When you have two lines crossing, we have 1, 2, 3, 4 different regions, okay? In this case, this is the region which is the solution, okay, this one. So again, let me separate them in the following manner. This is dashed, this is solid, this is the solution. Very Straightforward, everybody. Y is larger than 2/3 x plus 3, 2x minus 3y is larger than or equal to 3, and we are supposed to graph the solution set for the system of inequalities. So we start with this one and we write it as equality. We want to graph this line, we are going to go with the intercepts. Obviously, we have 0, 3. And if you set y equal to 0, I hope you recognize you solve this. You get -9/2. Let me just quickly show you. If you put 0 equals 2/3 x plus 3, you can multiply by 3, you get 0 equals 2x plus 9, and x becomes -9/2. Okay. So you plot those two pairs, and the line is a dashed line because we don't have an equality. So again, take a look at this point, coordinate 0, 3. This one -4.5 or -9/2, 0. Which side is the solution? You pick up a test point because 0 is not on the line. That's a good test point. So we are going to put that into the original inequality, meaning this one. So if I put 0 larger than 0 plus 3, that means 0 larger than 3, it's a false statement. So this makes it false. The other side is shaded as a solution. So we're done with the first one. We go with the second one, we do the same thing. We come up with two pairs. So first we make it into equality. If x is 0, y is -1. So just cover that. If y is 0, that means cover that. X equals 3/2. Plot the two pairs as 0, -1. 3/2, 1.5. 0. Since 0, 0, this pair, the origin, doesn't belong to this line, that is also a good point to use it as a test point into this original inequality. Replace the x and y with 0, you get 0 larger than or equal to 3. That is also a false statement. So that means this is not the solution. This side is not the solution. The opposite side is shaded. Now, you may recognize the two lines are as parallel because clearly the slope is 2/3 here. Over here, if you solve for y, divide by -3, divide both sides by -3, you get y equals 2/3 x minus 1. So they have equal slopes, 2/3, different y-intercepts. The y-intercept for this one is +3, for this one is -1. So the lines are parallel. Since the shaded region do not overlap, there is no solution for the system. So very straightforward. One is subsystems of linear inequalities consisting of absolute values. For example, you remember absolute value of x is less than a, and if a is positive, x is sandwiched between negative and positive a. And if it's larger than a and a is positive, x is less than negative a or larger than a. So in this example, we are graphing absolute value of x less than 3 in the Cartesian coordinate system. So basically, what this means is x is sandwiched between negative and positive 3. So x is equal to negative 3. You draw a line, which is a vertical line. X equals 3. You draw a line. I hope you recognize this as x equals negative 3. And this one as x equals positive 3. And anywhere in between. So you have two vertical lines. And you really don't even need a test point. It says x is between negative 3 and 3. If you were to graph this on a number line, would go from here to here. That's it. But Cartesian coordinate system, then it's different. You're dealing with two lines. That's extremely important to pay attention to. Example 11, we want to graph the system x plus y larger than or equal to 3, x minus 1 less than or equal to 3. And the idea is to find the intersection of the regions. That's what we have been trying to do. So we start with the first one. We change it to an equality. To graph this, we're going to pick up two pairs in intercepts. X is 0, y is 3, y is 0, x is 3. So we have the two pairs. 3, 0, 0, 3. And we have a test point. 0, 0 is a good point because it's not on the line. And again, these are, by the way, the intercept. So when we plug in 0, 0 into this, we get 0 greater than or equal to 3, which is a false statement. So put 0, 0 into the original inequality, false statement. So this is not a solution. The opposite side is the solution. And the reason this line is solid, because we have the equality in the first place. Now the second one, x minus y equals 3. We pick up two pairs by setting it equal to 0. If x is 0, y is minus 3. If y is 0, x is positive 3. And here's the line. And again, we can pick the origin as a test point because it doesn't belong there. So you plug in 0, 0 into the original inequality, and 0 minus 0 less than or equal to 3, 0 less than or equal to 3. That's a true statement that works. We shade this side. And so basically, the solution set is to put this together. So when we put them together, they look like this. So again, as I mentioned, it creates 1, 2, 3, 4 regions. Whenever we have two lines intersecting, they give us 4 regions. The solution set is when these two come together, which is here. So that's the first one, that's the second one, and that's the solution set, this region. Very straightforward, everybody. We want to graph this inequality y is between -1 and 5 inclusively, so that means basically you have two horizontal lines, y equals -1 and y equals 5. So it's a system of inequalities. Y is larger than or equal to -1 on the one hand, on the other hand is less than or equal to 5. That's the meaning of it. And that's an and statement. So the best course of action is to draw the two lines. This is y equals -1. So above that, this is y equals 5. Let me write those. So, well, okay, and that's below that, and they come together here. So just draw the two horizontal lines, y equals -1 and y equals 5, and shade the region in between. That's the fastest and easiest way. So I'm going to write y equals 5 here, y equals -1 here, and it means just in between. So again, the point is, can we go this route? Yeah, but it's the fastest way. All right. Graph the system x minus y greater than or equal to -2. X is less than or equal to 3, y is larger than or equal to -x. And those are the color of the line. So each one creates an equality. So let's go with the first one. X minus y equals -2. That's the first line, everybody. And if x is 0, y is 2 because minus y equals -2. And if y is 0, x is -2. So those are the two pairs. This one, just the line x equals 3. That's a vertical line, everybody. For the red one, y equals -x. It goes through the origin. 0, 0, and pick a number. 5, -5, 10, -10, 1, -1. Okay, so that's the blue line. This is the green line. And the red line 0, 0, 1 minus 1. Look at those points of intersections. The solution is shown and the vertices are labeled. These vertices can be found by finding the intersection points of the pairs of lines. Just to give you an idea, for this one, let me So for this line, y equals minus x, and this line x minus y equals 2. So all you have to do, replace the y with minus x. You get x minus minus x, or true x equals minus 2, so x is minus 1. And if x is minus 1, you can put it into y equals minus x, and you get positive 1. So that's the point of intersection. For these two is easy, because x equals 3, just x is 3 here, x is 3 here, x is 3 anywhere. So if you put it for the blue line, x is 3, 3 minus what number is negative 2 is 5. And you put it into the red line, y equals minus x. If x is 3, y is the opposite of that. So it's very easy to find those intersection points. If you do a test point for each one, and I'm going to leave it for you to do that, that means do it for this line, becomes this way, just for the sake of argument. If you put this into this, 0 larger than or equal to negative 2. Look at the blue line. 0, 0 is here. Is this a true statement? Yes. So it gives you this side. So you can try the green one. Obviously, x is less than or equal to 3 is this way, and y is larger than or equal to minus x. You cannot use 0, 0 because 0, 0 is part of the graph. Okay, so for this one, you use, for example, this one, negative 2, 0, just as an example. And if you plug in negative 2, 0, 0 is larger than negative 2, that means positive 2, that's a false statement. So it's the opposite side. This is the region that works for all three. And I want you to try, make sure you can find that. This test point does not work for this one. So the test point for this one can be, for example, 1, 0. I don't know, 0, negative 1, negative 2, 0, okay? So the test point works for some of them and not all, okay? The test point. It's important to understand that. All right. We are going to move on, everybody. Find the solutions and sketch the graph of the inequality y squared is less than x plus 4. We're going to replace this with equality, and that gives rise to a parabola y squared x plus 4. I hope you remember from previous courses that this is a parabola that opens sideways, okay? In essence, you're dealing with x equals y squared minus 4, okay? Because it's quadratic with respect to y, it opens to the right or left. Because the coefficient of y squared is positive, it opens to the right, just to give you an idea. So you can find the intercepts easily, okay? If x is 0, y squared is 4, you get 0 minus 2, 0, 2. And if y is 0, you get x equals negative 4. So result, a parabola symmetric with respect to the x-axis. As I said, it opens to the right. We will discuss that later on again when we go over the analytic geometry. X-intercept and Y-intercept. X-intercept, Y is 0, X becomes -4. Y-intercept, X is 0, Y squared equals 4, plus minus 2. So 0, -2, 0, plus 2. Again, this one, set Y equal to 0. That means 0 equals X plus 4. This one, set X equal to 0. That means Y squared equals 4. That's how we arrive at those. And since the inequality is simply less than, we don't have the equality, we have to go with dashed parabola. It's a dash parabola. All you have to do, pick up a test point. You can plug in 0, 0 into this one. If it works, inside is the solution. If it doesn't work, outside is the solution. I'm going to go over what they want you to, but just right here, I would just check 0, 0. If I put 0, 0 here, so I want to tell you how I would finish it right away. So right here, I'm going to go with the test point because you have two regions, inside and outside the parabola. If I put 0, 0 as a test point, TP, I put 0 less than 0 plus 4, 0 less than 4. That's a true statement. So I would say the region inside. And I'm done. Okay. But let's elaborate on that. So we are going to say, let's check this one. We can do both. -5, 0 if you plug in. So y squared, 0 squared is less than -5 plus 4, 0 is less than -1. That's a false statement. -5, 0 is not a solution. So right here is really good enough. Let's also use 0, 0 as I showed. 0 is less than 4. Yes, it's a true statement. It is a solution. So points to the right or inside, point to the right of the parabola or solution. So we shade the region as follows. So I would just do one of those test ones. You'd have to do all of it. Two is not necessary. One is good enough. It shows inside or outside. Linear programming and the concept of a constraint. Linear programming is a mathematical process of maximizing or minimizing the quantity subject to several limiting factors. In a linear programming problem, the limiting factors can be represented by linear inequalities called constraints. Here's an interesting example of that situation. Jose is landscaping his yard with some trees and bushes. He would like to purchase at least 3 plants. The trees cost $40 and bushes cost $20. He cannot spend more than $300 for the plants. Write a system of inequalities that describe what Jose could purchase, then solve the system by graphing. So let's go with a table. We have plants. The types are trees and bushes. The cost is $40 for the trees. Bushes, each one $20. How many of each? We have no idea. How about X and Y? X represents the number of trees. Y represents the number of bushes. We want at least 3 plants. That means X plus Y must be larger than or equal to 3. And we can't spend more than $300. So the cost will be 40 times X plus 20 times Y, and that must be less than or equal to 300. So one more time. This one says X plus Y must be larger than or equal to 3 because that means at least. And this one is the cost of trees, 40 times x. This one is the cost of bushes 20 times y. When you add them up, we can't spend more than $300. So it must be less than or equal to $300. This is an example of linear programming. So we are going to solve this. And by the way, with a case like this, we live really in the first quadrant where x is positive and y is positive. I want you to know that. So this is the x, this is the y, and both of them are positive. So first, we change this to equality. X is 0, y is 3, y is 0, x is 3, so we get the two pairs. 0, 3, and 3, 0, we can plot the pairs, graph the line. This goes indefinitely on both sides, but again, remember, just in the first quadrant. Now, we pick a 0, 0 as a test point. That's good enough. Put it into the original inequality. It either works or it doesn't. When you put in 0 plus 0 larger than or equal to 3, that's a false statement. So zero, zero doesn't work. So that means the opposite side is the solution. So that's for this case. For this case, we change it to equality. Choose x equals 0. This goes away. 20y is 300 divided by 20, and you get 15. So 0, 15. Choose y equal to 0. This goes away. X is 300 divided by 40, which means 30 divided by 4, which means 7.5. So 0, 15, and 7.50. This is not to scale. 15 is up here, but this is not to scale. It should be here. And you draw the line. Again, 0, 0 is a good point for the test point. You put it into the original equation, you get 0 less than or equal to 300. The answer is yes. That's a true statement. So 0, 0 works for this guy. For the blue one, you shade this region. So they come together between the two lines. So here's what's going to happen with this type of equation. Any ordered pair in the overlapping region. So let me do this so everybody can clearly see what we are referring to. What color do I pick? Let's go with green. This is the overlapping region, okay? Any ordered pair is a solution. Assuming that only whole trees and bushes can be purchased. Of course, you can't purchase 2.5 trees. Only whole numbers would be in the solution. For example, 4, 2, look at this point. 4, 2, 3, 4, this point. So let me actually, those are examples. So there are infinitely many solutions. This is one possibility. This is another possibility. The point is, it doesn't have a unique solution. Any one of them will do the job. This is known as linear programming.